So again, some things we're going to look at. If we can, we're always going to factor first. And then if two factors are identical with multiplication, and this is important because sometimes when we get to algebra, we sometimes work with rules and forget what is actually happening, which is a dangerous thing. We want to understand what's actually happening to see where things are going. But as soon as we get into something abstract, it's sometimes hard to understand it at the same time. So I'm going to be going back and forth with regular numbers to show you why this is true. Okay, so you've simplified fractions before. For example, you could simplify something like 28 over 21. 28 over 21, and you might be really good at this. You might be able to say right away that it's 4 over 3. And you could see that the top and the bottom both could divide by 7. And that's a skill that you've developed, and that's great. The step that we do, that we don't write with numbers, but we could, is you could have factored this. Technically, 28 is 7 times 4. Technically, we could even do the prime factorization and do 7 times 2 times 2, if we wanted to. And 21 is 7 times 3. But we don't write this step with numbers anymore because you're good at it. You can skip it. And because you can skip it, you run into trouble in algebra because you don't realize what you're doing in the same way. So this second point, if factors are identical with multiplication, they can be simplified. And this step in between says, oh, I have a factor of 7 on the top and a factor of 7 on the bottom. I'm multiplying because I have 7 times 4 and 7 times 3. I can simplify by saying 7 divided by 7 is just 1. And multiplying by 1 doesn't matter, so I can simplify those 7s. And I just get 4 over 3. But since you're pretty good at numbers by now, you skip that step and go directly to here. But we won't be able to skip that step in algebra as easily. Okay? Sometimes, like in example, in the first example, in part A, it's already all multiplied together. The number part, you probably could simplify just doing what you normally do. How would you simplify 25 over 35? You'd probably say, hey, they both divide by 5. And you would say, I'm left with 5 on the top and 7 on the bottom. No problem. Then we have a cubed on the top and a on the bottom. A cubed means a times a times a, if I wrote it out broken up. And I have 1a on the bottom. Can you see that 1a on the bottom would cancel out with 1a on the top? And you'd be left with a squared. I have 5b's on the bottom, and I have 2b's multiplied on the top. Can you see once, like if you wrote it out, and we wouldn't do this, because it has to write a lot of b's. But can you see that they would simplify? 2 of them would go away. And you would be left with the cubed on the bottom. And we have a c on the top, and we would still have a c on the top. So the first one is already written as multiplication, and you can just simplify it directly from there. There was no need to officially factor it, although I guess if you wanted to, you could have done this. Right? You could have done that. But because this one is relatively easy, in fact, this same question would have been done in grade 9 math, This kind of simplifying in part A is from the grade 9 curriculum. We don't need to write this all out and go, okay, these ones simplify, these ones will simplify. What am I left with? I'm left with a negative, the 5, a squared on the top and a c, and on the bottom a 7 and 3 b's, so b cubed. But you could, right? And if you ever forget, you can go back to that. That's the nice thing. But in part B, we can factor. On the top, we are adding. And this is important because we can simplify if we're multiplying. We cannot simplify if we're adding. Although you will be tempted. Unbelievably tempted. I'll warn you, you will be like, ooh. You get so excited about simplifying, you will be tempted. You can, like, check it out. Are you allowed to do this? 5 plus 7 divided by 5. Ooh, I'll cancel the 5. It's equal to 7. No. I hope you can see that 5 plus 7 divided by 5 is not even close to 7. This is like 12 divided by 5. It's not going to be 7. But you won't be tempted with numbers. In numbers, you'd be like, I got this. It's 12 divided by 5. But in algebra, you will see, oh, number on top, number on bottom. I might be really tempted to cancel out those x squareds in part C. Not allowed. And this is why it's not allowed. You check regular numbers and you can see why you're not allowed to just cancel out those 5s. So in what we do is we factor first to change it to multiply. So if I factor in the top, I have a common factor of 6x, leaving me with x plus 2. And now I'm dividing by 3x. So now we have changed this technically to multiplying. And I could change the 6 to 3 times 2 if I wanted to, but usually for the numbers, because you're good at the numbers, we don't have to do that in depth. Okay? Can you see that now that you're multiplying, that x divided by x would be 1. 6 divided by 3 would be 2. And the answer to this is 2x plus 2. That's its simplified form. And often in its simplified form, we leave it in its factored form. Technically, we could write that as 2x plus 4 as well. I'm wondering, does the answer key write it as 2x plus 4? No, they kept it factored. The answer key is also, if I look at the bottom, and did it ask for this? It didn't ask for this, but they're also listing the non-permissible values. So in the first one, can you see in the first equation that a can't be 0 and b can't be 0? Those are our non-permissible values. I will use NPVs for non-permissible values. And for the second one, the non-permissible value, what would make you divide by 0 is when x is 0. So that would be a non-permissible value. Oh, see, so tempted to cancel out those x squareds, but you are not allowed to because you're adding and subtracting. Technically, when you're adding and subtracting, currently you only have one factor on the top, because adding and subtracting groups things together as a single factor, and one factor on the bottom. And unless a factor is identical, it doesn't simplify. But if we factor the top and we factor the bottom, the top is a difference of squares. X plus 7, x minus 7. The bottom is a trinomial that can be factored. It also will be x and x. To get 14 and a minus 5, we would need 7 and 2. The 7 would have to be minus. The 2 would have to be plus. Multiply it out in your head to make sure that everything works out. And now we're multiplying. Do we have two factors that are identical? Yes. Very nice. And it simplifies to x plus 7 over x plus 2. Non-permissible values in this one. X can't equal 7, and x can't equal minus 2. The last one was 2x squared minus 5x minus 3. The bottom was 9 minus x squared. The bottom is a difference of squares. 3 minus x, 3 plus x. The top will be 2x and x. And to get the 3, you're going to have to do 3 and 1. Now it's either a 3 and 1 or 1 and 3. And it's different because of that 2x. Because this is a grade 11 rational unit question and they want you to simplify, there's sort of a cheating way that you can kind of, like, if I was going to guess and check where I should put the 1 and where I should put the 3, I'm going to guess that the 3 is going to go here because they want us to simplify. So I'm going to need an x with a 3, most likely. So this would be my first guess. Now I'm going to check. Is it possible to get minus 5? Well, if my outside was minus 6 and my inside was plus 1, that would give me minus 5. Again, multiply it out when you're done to make sure that you're right. This one is interesting, because I hope you notice right now that things are close, but nothing matches up perfectly. Why? I have an x minus 3. Is that the same as a 3 minus x? Not exactly. However, maybe we write this as a special note that sometimes when you have factors that are almost the same with a minus sign but they're flipped, you can factor out a negative 1. If I take a negative 1 out of here, can you see that that would make the 3 negative and the x positive? Taking the negative out of the 3 would make the 3 negative. Taking the negative out of the negative x would make the x positive. And so, taking out a negative would allow me to switch that. And now if I rewrite what I have, so on the top I have 2x plus 1 and x minus 3. And on the bottom I've now factored a negative out. Yeah. 3 plus x is the same as x plus 3. That one doesn't matter the order. Now my factors are identical. And I can simplify this to be non-permissible values in this one. X can equal 3, and x can equal negative 3. So now I want you to start practicing some of these questions. So also circle questions 7 and 11.